starting up. Okay, so very cool file so far. Looks like some really good projects coming along and making some alterations and such. Excellent. So I'm just going to open. I know this is not the badge. Oh, wait, I did have the badge. So why don't I open the badge? My badge. Okay. So the blah, blah, blah emblem. So great. We have this. Now what? Well, now we look at printing. Pardon me. So as I said, we have two different options. And I will pull up, I'll go back to the filament printer versus the resin printer. As I said, for the most part, this is the model that we have of the filament printer, the extrusion printer. This is the model we have, and we can work with just printing vertically. It will print flat on the surface. But as I said, some of these, the text, and as I flip back to here, some of the text sometimes is a bit too small for this printer to handle. And at that point, we will have to switch over to one of the resin printers. Now, I don't have examples up right now, but we'll explain this more later. Now, how do you get from your file to one of these printers? Well, they both have their own what's called a slicer program. And as I said before, as how these printers create a three-dimensional object is it takes your virtual three-dimensional object and it slices it into a whole bunch of very thin levels and stacks those levels together. Now, technically, Fusion has a built-in option. We're not going to use that because it's more of a general purpose one, and it's not always as effective as the other programs. The programs we have, and you can download those for free. I'll put the links up because I just didn't think we'd get here tonight. And I'll open both of these up. The Formlabs resin printer has its own proprietary software. Prusa uses a open source printing software slicer program. Now, let's see. Is it going to give me a option? Great. So far, not so much. So the cool thing is in both of these, it will create a virtual environment, meaning it just has a virtual representation of the platform, and the Prusa has a built-in grid. Each of these is 1 centimeter grid. So the cool thing is as you import a file, you immediately have a sense of how big this is. Cool. The resin printer, let's see if my computer crashes with opening all of this, opens its Formlabs software called Preform. You can get either of these from their respective websites. I will put links onto Blackboard for both of these. You do not have to have these on your computer to print because I'll be printing for you. You can send me just the file and I will load it into this software, but I'll show you how this all works by doing just that. And this is also why, because these don't necessarily correspond to anything, but I'm just going to go through. Yes, sure, fine, options. Yeah, it still went back to a Form 3. Thanks, computer. You're the best. I'll do the update later. As I said, probably going to have updates. Formlabs also gives a virtual environment, but this is not a direct correlation. But it does give you reference points of where the front of the printer is, and wiper is referring to it. Pardon me. It actually has a physical wiper, much like wipers on a car windshield, that it squeegees back and forth into the resin tray. It just keeps the liquid fresh. That's all. But cool. What the hell do we do from that? All righty. Going back to your project. All right. I've looked at all of it. I'm going to hide the sketches because it's slightly less confusing. I have my super strange, wonky, blah, blah, blah emblem. To go from here to get to those programs. You go up to File. Now, it does have an option to 3D print or export. Before we used export to get what we wanted to get our file out, because we were saving this as a Autodesk file that we were going to offload, or we exported from your personal team and brought it to our shared team. This is not what we're doing here, nor do you want to use a different file format. We are going to generate a completely different option. Click cancel, go back up to File. You have 3D print. And as it says here, it will convert whatever you're working on into an STL. That is what they were talking about, a stereolithogram. All of those multiple little flat images and stacked together to create a virtual object. That's what it'll create. So click 3D print, but we're not going directly to a 3D print option. So where it says output, make sure that you have expanded this and deselect the checkbox. You do not want it to go to a 3D print. Now, problem is I haven't selected anything. That's because if I had multiple objects in here, I could select just one and export just the one, but I just have the one thing going, so that's fine. Easy way to select that, if you do have multiple parts and it keeps not letting you select, you can expand the hierarchy tree and just select the actual object badge out of the hierarchy tree. Same deal as just selecting it, but there you go. Hit OK. Now it brings up, where's last saved, STL files. Badge, there we go. I'll change it to Collins badge so I can keep some of this stuff slightly straight in my brain. Okie dokie. That is now exported from there. Go to the file or the folder I have it in, and oh my God, so much crap. Where did it go? There we are. So the files we made before, that F3D, the Fusion or the Autodesk Fusion file, different icon. Here you have an an STL file. It's a 3D object file. If you're using Windows, Windows now comes automatically with a 3D object viewer. It's just like opening a picture in a picture viewer, only it's a three-dimensional object. I can double click that. Neato. Now it's showing me the 3D object in a virtual space. This is just another virtual space, just like anything. And I just realized this thing looks like two fingers. Robot finger meets hand finger. Cool. Whatever. Just another way to view a file. Don't need that. What I do need is to bring that into one of these prep folders. Yeah, my computer is definitely bogging down now. Keeps doing this weird floating thing. All right. So with either of these, you can either go to File and import an object, STL object, whatever. We'll go over the specifics of what those are later. Or I can just click and drag. Bloop. So I did not size this before. Way too big. Like I said, not a problem. If you have the wrong scale or something, we can just simply scale it down. You can do this numerically. So right now it is reading 320 millimeters by 235 by 35 tall. This is right now freaking huge. Or I can scale it down by factors or below 100%, or if I'm scaling it above 100%. So I'll just dial that back to 50%. You can just do any one. It says X, Y, Z. These refer to the axes, just like in Fusion. Any one, and it links all of them together. Now it's only 50% as large. Hooray. Now on these tools, on these programs, you'll have some other tools. You'll have multiples. You can arrange these. Say I wanted to make more of this. I can copy paste So I'm on Windows, Control C, Control V, made another one. And I can go to this icon, which is an auto arrange. Now it's not going to work because these are already too large. If I scaled these down more, yeah, that would work. It's like 25%. Now both of them will fit. So that's all. But I don't want that one. I want to use the 50% one. Arrange, and it just snaps it to like the most reasonable spot. That's all. If you wanted to drag it around, you could do that too. That's handy for when we're printing multiple items on the same platform. But for now, yeah, sure. We're going to get into the specifics later. But for right now, this is basically the build space. You can select the quality. So this is how large each layer is. So like I said, it's determined by the size of the nozzle. That's how large the extrusion is. But what this is referring to is how high the increments are, how high it raises the print head or the object each level. So that's what that's referring to. And it just tells you some stuff of like, oh yeah, it's quality. It's much finer, going fast, or quality. Basically, it's just like if you're printing on your home printer and you just need it to kick out some prints, you can select how heavy the ink is. You can select high quality. It'll print a really nice quality print. Or if you just collect draft, it'll only use a little bit of ink and just shoot it out as fast as it can. So that's exactly what it's referring to. The other options it has is what your material is, because you have to know what material you are using per each. Now you can always go and say, save this one and do it again in a different print, a different material, no problem. But the printer will automatically adjust for what material, because different materials are printed or extruded at different temperatures. So PETG, that's one of our standard ones. For the most part, we're going to be using generic PLA. Stands for polylactic acid. Doesn't really matter, but that's what it stands for, if you're curious. It's a general printing filament. It's cheap. It prints nicely. It's not overly strong, but it usually looks pretty good. So that's pretty much the thing. And it comes in a lot of colors. From there, that's a standard thing. Looking down right now, the supports, you don't need to mess with that because we're printing a flat item. We will adjust it for that later in the semester. Now, infill is right now you are printing, you're just seeing the outside, just the outer shell. A filament printer, an extrusion printer, basically prints the shell and will create any variety of shapes, but it will create a mesh web inside. Think of if you've ever seen like a bird bone cut in half. I know, like, what the hell? Where's that coming from? How birds have hollow bones, but they're not completely empty inside. They have like a mesh web inside. That's what it's referring to. It keeps the print stronger, but it keeps it lighter. The lower the percentage, the lower amount of material it's making inside. The higher the percentage, like 100%, yeah, it's just telling me you shouldn't do that in full 100%. It will print it solid. Don't do that. He uses a lot of material. But that's what that's referring to. So at the bottom here, now, of course, there's a bunch of other options, and we will get into those as we go along. But at the bottom here, it says slice now. It is going to take that three-dimensional object and chop it up into all those layers. And the cool thing is now it's an updated program to where all of these little lines and such it's showing you, that's actually showing you the path of the extruder, because it's just that one little nozzle. So the lines between gives you a pretty fair idea of what the object will look like once it's printed. All those little lines represent the actual extrusion coming out. Like I said, it comes out just like if you're using like a hot glue gun. It comes out as kind of like a squirted tube, I guess, or toothpaste if you need, whatever your chosen liquid squeezed from a tube goes. But that's what that's referring to. You can see the sides. It has those layers. It has those lines. It's really neat. but referring to infill. And the reason these are different colors is just you can look at the legend. It's just referring to things that are vertical, things that are flat. That's all. There's a slider to the side here. And by the by, I'm not expecting everybody to get this right off the bat. I'm just going through the motions so you can start to become familiar with this. It's not necessarily relevant for what we're doing just yet. I can slide through this and you can actually see the different layers, and this is really cool. You can now get a sense of what that infill looks like. Now, right now, I have the what's called gyroid infill pattern selected. I like that the most. It's strong, but it takes fewer back and forth motions of the print head, so it prints a little bit faster. There's all kinds of different ones. There's squares, there's triangles, but like I said, kind of like looking at the inside of any kind of bird's bone. It's hollow, but it has web mesh inside. So that's what it's doing. And you can zoom out and see that all the way through. And it'll take you all the way through the different layers. Now you see like that whole flat area. Now you see what that looks like inside. So that's what that is. Now, the other thing, as I said, a concern is text can be too small for this printer to print. And let me zoom in and you can see what I mean. So since this is a virtual visual representation of each of the strands that gets extruded, you can see as I zoom in, and let me pivot upward here, you can see what the limitation is. Right now, it's basically that text is only big enough for the printer to print basically an outline and a teeny tiny bit inside. Any smaller, it probably would not be able to print this. So this is where you might want to, if you have text, make it a little bit larger font. That's all. So go back to 100 just because. You could export this. It's called G code. That's just general code for computer CNC machines. You can send me just that file if you would like to control the specifics, but I need to know. But if you do that, I need to know what that is, like what your specifics are. Like, it will not automatically show me in the file. Oh, actually, no, the new versions, it will tell you what the material is and all of that. Pretty cool. So that's where that goes. You hit export, comes up in the file code. You see the type. It's a G code file. Do not change that. It gives you your name, but I forgot the newer version does actually give all that information. So really cool. It does tell you it's what the thickness is, what the material is, and it also gives you in that an estimate of how long it takes to print. You can see that, and I'm just going to cancel this. I don't want to save it. But in the sliced info, it will give you an estimate as well. The amount of filament it uses in meters, it uses a lot, but that's not actually that's in the extruded, not in the coil. Different size. Don't worry about it. But this is what I was talking about. A filament printer, it takes a little bit longer because it's actually extruding. It has to go slow enough for the thing to cool as it moves along. So yeah, even that little thing takes about 4 hours to make. It's not like that's a restriction or requirement, just good information to have. All right. What if this was something I wanted to make on the resin printer? Okay. Same. I can just click and drag and drop. Now, the preform program for the Formlabs printer, the resin printer, it will automatically shrink the model to fit inside the bounds. So I'll click OK, but that doesn't necessarily mean that I don't want to make it a different size anyway. All right, so it's given me a good rundown. Now, one of the issues with a resin printer, or rather just how it goes about, a filament printer, you can print a large object flat on the table, flat on the build platform. A resin printer, because it's actually the way it's actually printing, and let me go back to the layout. You can see this is how it prints the object. It's gravity flat on a tabletop, flat on that work pad, and it's stacking layers. The Formlabs, and this is not true of all resin printers, but quite a lot of them. You have a tray of liquid resin at the bottom, but at the top is the actual platform. So it prints it upside down. So flat things don't work as well. That's not meaning that you can't print it. It just means you cannot print it flat. So what you have to do is just change the orientation a bit. So I'm going to go up to some of the options here. And your top left-hand side, you have size. I already wanted to scale this thing down a bit. So let me make sure to select it. And I want to make that like, I don't know. Let's go with 0.25. It's a scale factor. That's all. Oh God, not that. Scale factor from down from original. So anything below 1, 0.25. Not reset, hit enter. There we go. Now that's a much more feasible size. Okay. Now I want to rotate this. I could auto orient it, but like I said, it might not automatically do it. Let's see what that oriented it to. Okay, great. The new version actually will tilt it to an optimal angle. So you don't have to do that by hand. You can do it if you like. So you can select this and I can orient it. I can click and drag. I can scale automatically. I don't want to do that. Control Z. I can use this round sphere here. You can grab that and that's how you can rotate it around. But I'm going to go back to auto orient. Let the program do its job. Okay, cool. So it is oriented. It's about 15 degrees up. It's just because with a resin printer, like I said, it's hanging from above. It doesn't do flat objects very easily, at least not oriented flat onto the print bed. Angle it a little bit, all good. Now you can go to supports. Now it'll do all of this stuff automatically, but I'm just going through the steps of what happens. You can, of course, make alterations, but I'm going to let it go with just the standard settings. And I'm going to have it auto-generate supports. Because obviously, you can't have this thing just suspended in mid space. We don't have anti-gravity printing yet. Probably be a little while before they do that. So it's going to generate these supports, and you'll see what happens. Oh my God, that is a mess. So it's going to create all of these supports, and that is so many. So that's the automatically generated support structure. Yeah, it looks like a bunch of scaffolding because that is exactly what it is. So we're going to dial that back a bit. So let's try, it's the same, basically scale factor. So we're going to dial that back to, let's try 0.75 and hit enter and do it again. Why isn't it generating? Takes a bit to calculate all of that. Waiting. While it's waiting, you can look to the right side of the screen here, and it gives you similar estimates. Print time, still 3 hours, probably because it's printing all those freaking scaffolding. Tells you how many layers, that's how many actual cut little stack pieces, and it gives you the volume of resin used. It's quite a small amount, 28.5 milliliters, not a lot. All right, that's still really dense. So I'm going to dial that back one more time. And by the way, I am just doing this just doing this by eye because that's a lot of print or a lot of supports. Don't want that many. Realistically, the reason it's generating so many supports is because it's a pretty low angle. It's only at about like 15 degrees. If I go back and change that, it'll do it a little bit more sparse. Still pretty much the same. So let's do exactly that. I'm going to go back. I'm going to orient the object myself. So orientation axis, this is exactly the same as your others. So right now, let's change that 45. That might be a bit more reasonable. Let's try that. Now I got to auto-generate. Yes, always the waiting for calculation. Cool. Uses a lot less material by half. Now it is giving me a warning. There's this little red hue area. It's giving me a probability error warning. All right, that's fair. So maybe we need to go back and change this around. So basically, go through the motions. The problem with this is I can do all of these options. Same thing, the layout, that'll make it change. Same thing is with the Prusa, with the slicer there. The export, slice, whatever, is start print. Problem is with this, you need to actually be physically or networked connected to a printer. So that's why I say it's going to be best just to export and email me the bare file, and we can discuss what you want out of it. So wanted to go through the paces with everyone, show you what is involved. But that's pretty much all of that is what's involved in getting a print ready. So again, I know I'm throwing a whole bunch of information at everybody. Please don't feel overwhelmed. Yeah, great. Easy for you to say, Hoss. There's a lot going on, but we're going to go through this step by step when it's time for, or when people are ready to go through that. I just wanted to give everybody a rundown of these are the steps. That's kind of what to expect. But in the meantime, work on your badges. Please let me know if you have questions on anything. And if you'd like to, we can set up an appointment and go over it individually. But that's pretty much what I had for everybody for tonight. So work on your badges. We'll work on getting stuff printed. And I will stop the video there.